Optical illusions aren't just parlor tricks or something to dazzle the eye. They actually affect your art, either positively or negatively. And it's in my book, Ellen's Guide to Design Elements, on Amazon. Let's start with the stovepipe hat illusion, where the vertical line looks longer than the horizontal one, even though they're the same length. And when I turn it into lines, this vertical line looks longer than the horizontal one. And a common explanation is that we're better at judging horizontal rather than vertical distances. But I disagree with that explanation because when you turn it around, now the horizontal line looks longer, indicating that the illusion is not due to the direction of the line. It's probably because this supposed long line divides up the supposed short line. So a divided line looks shorter than an undivided line. If we have both of them dividing the other one, then the illusion disappears. For the Muller-Lyer illusion, this line with outward pointing arrows looks shorter than this one with inward pointing arrows. But if I change the arrows to ellipses, this line still looks shorter than this one. And I think it's because this overall is a shorter image than this one. And it's also not about which corners they are, because most corners have both inward and outward pointing arrows. This one, for example, points inward while this one points outward. This one points inward and this one points outward. Now look at these corners. They're sort of interesting. This top corner looks like a corner in the ceiling because this line is vertical, whereas this corner looks like a corner on the floor because this line goes along the same direction as these lines. In this first image, the zigzags change direction at the horizontal lines. So this pattern looks almost three-dimensional, where it protrudes out here and seems to recede here. This is similar to patterns on dresses and tablecloths that should look flat. So if you have this pattern, look at it and see if it looks three-dimensional and see if that's what you want to achieve. Now in the second pattern, the zigzags don't change direction at the horizontal lines. So now, when the zigzags go in this direction, the horizontal lines seem to come together in this direction. Similarly, when these zigzags go in this direction, the horizontal lines seem to converge toward this direction. This is the herring illusion, where these red lines seem to curve around the center here. And this is relevant, for example, if this were sun rays in the evening with a reflection in the water. It is also relevant if you're drawing a window with siding, and these vertical lines may look like they circle around the vanishing point here. And so the remedy is to de-emphasize these diagonal lines. The cafe wall illusion makes horizontal lines appear to slant, and I drew two red horizontal lines to show you that they are in fact horizontal. So the squares need to shift and you need to see these lines between them. Over here, I put the pattern in without the horizontal lines. So it looks like a pattern that you might see on a dress, or it looks like bricks. And when you put in the horizontal lines, that's when the bricks appear to slant. So keep this in mind when you're drawing bricks. For this second optical illusion, this line on top appears to continue below as this blue line, whereas in fact, it lines up with the red line. If you switch the colors down here, then the illusion becomes much weaker. This looks like a spiral, even though it's in fact lines along concentric circles. So follow this black circle and you'll see that the lines are both inside and outside that circle. The reason it looks like a spiral is because the lines have more continuity with the lines on the next circle than they do lines on their own circle. Now, this is a true circle and this is a true square, but when I put them against these patterns, they both look distorted. Check out my book on Amazon, Ellen's Guide to Design Elements, and please remember to subscribe.